season extension, you've had a chance to just peek a little bit at some of the greenhouse structures that Josh showed, like the big cold frame and the summer kitchen and the G animal when we did the orientation last time. And we'll go out and take a walk, maybe to show you the other side of the farm and go over and see the big high tunnel before we get started on our outdoor activity this afternoon. But I guess maybe just hearing from everybody, Josh, about kind of your interest in greenhouses, if you have one, and like some of the questions you have. I know, Steve, you had some questions about material choices and other systems that can be used. It's a huge topic, and we both have experiences with our own structures and other people's that we can share and resources. So we wanted to kind of see where the group's at first.
We're looking at right now, when I say we, I work with a couple engineers at the VA in Boston.
Yep.
Both interested in what I'm doing and both interested in the project up on the building project we're going to do up on Hall Stream in Pittsburgh. And we're looking at creating a thermal bank so we can have a 365-day-a-year greenhouse, combination aquaponics center, because we want to raise tilapia. Mm-hmm. And we have plenty of space. We have great exposure to the sun. It's just, you know, creating that thermal system with water and however we're going to do it.
Right.
And using the solid structure because of snow load and everything else. And like I said, something that we can pull fish out of there all year long and pull tomatoes out of there all year long.
Well, I think that's the fundamentals of this. The concept is really to create an envelope that is going to maximize the potential of this so-called greenhouse effect, which is more or less capturing the energy from the sun and storing it. So we need to be conscientious of the wind loads and the snow loads, and the system is designed to not only capture it, but also store that energy. So those components you're addressing are the fundamental. I would say as well, when we're getting into this discussion, that there's two major purposes that we're dealing with. You have a passive solar capacity to one of these structures that you could heat a building or heat water, or, you're just using this energy for heating purposes. And there's also this growing capacity, so figuring out ways to do food production or other plant material.
And I would just add to that it's also tied, just like in the design process we'll be using in the permaculture process, it's tied to what your goals are. So you can produce tomatoes and you can produce fish in January in Pittsburgh, but you will most likely need to have some energy inputs. And so if you're looking for a low energy system, then producing salad greens that don't mind freezing at night and maybe suspending some of your aquaponics for a couple months would be an option. So you get to really tie it to like what your goals are, where you want to use energy on the site, and how much you want to invest in the structure and in the systems.
Well, I can't suspend that system because it takes you so long to create the balance between nitrates in the water, and because the fish depend on it. Mm-hmm. So it's not like I shut it down for 2 months because then I lose the fish.
Right.
So it's a hard system to control in the first place. Yeah, that's weird.
So that's why for me, we're looking at capturing as much energy you can passively, somehow retaining it through tubular systems or whatever, because we have to heat the water because the roots for tomato plants need higher temperatures than the roots for lettuce. Mm-hmm. And tilapia needs it between 75 and 85 degrees. Mm-hmm. So we're kind of working that out right now.
There just are some limiting factors that we have to deal with. And this law of thermodynamics we're not going to be able to get very far away from. When New Hampshire gets down to -20 and it's the whole freaking state and the frost goes down in the ground, it's here. And so during those conditions, it really, all that embodied energy can really get drained away.
Even with a lot of thermal mass in water and in stone and other things, it gets sucked out fast.
And once the thing, it's fighting this tremendous, this whole state of cold. Once it gets cold, it can turn into an iceberg. If your thermal mass gets cold, mm-hmm. you're not going to be able to hook it back up. So it is. There's some science to it, and the great thing, thermal mass and so forth. If it was more transportable, it would be great. And the one form we have to do that is liquid. So there's ways to move liquid around, deep in the ground. Groundwater heat pump might be a great way for you to.
Well, the plan B is just putting the whole thing underground. Either an LED with solar, different grow lights, because they're doing it in California now anyway. I mean, underground gardens.
Yep. What are some of the other goals or questions related to greenhouses that people have greenhouse design?
Yeah, I'm going along the same lines you're going on, except I'm way past doing tilapia. I think tilapia in New England, I'm pretty convinced of tilapia in New England because of some of the things that we're talking about here. And then looking at some of the things that Filtrix has been doing with just heating the soils rather than heating the air.
Yeah.
I think we could do a lot more, growing on heat pads that are somehow cycled through the water, and then growing species that, for instance, bullhead instead of tilapia, that will survive at colder temperatures. Because I'm very interested in that whole aquaponics thing. My background is wildlife management, so I almost bought a trout farm at one point. So, but that's where I'm at. I'm looking at different species, and I'm probably going to start out with goldfish or minnows, because honestly, there's a good minnows or bait fish. There's a great market for that in the state. As a matter of fact, if you go to the state and you want to get a bait license, they will practically kiss you, because there aren't that many bait dealers around, and especially up where you are.
Yeah.
For ice fishing and all of that, the market is huge. So you got to get past the fact that I've got to grow a food quality fish, I think.
Well, it's the vegetation. I love tomatoes. So it's tough when you switch. I want to grow my tomatoes all year long.
You can grow tomatoes. I mean, looking at some of the information, and I just got exposed to it on Thursday and Friday. So
It's fresh.
I haven't really absorbed a lot of it yet. But they're growing in a cold house. No heat other than heating the soils, and they're keeping the soils at around 70 degrees.
Wow.
So, and they're growing now. Again, I haven't absorbed all of that, so I don't know how many tomatoes. I just saw pictures of the greenhouse, so I don't know exactly what they're growing in there. But yeah, I'm definitely looking at some, and maybe incorporating some kind of composting as part of that heat system. Because I think if you're going to beat the heat, totally stay away from any outside input. Composting would be one of the, incorporating some kind of compost into your bed.
Okay, so what we really got cooking here is the heat retention and distribution systems that we'll be looking at.
Yeah.
And the focus is whether, if you're talking about plants, the two components of the plants. You have your aerial part that's above ground, and you have your root zone. And if either one of those freezes with certain plants, you're sort of sunk. Tomatoes is almost, you get below 38 degrees.
Right.
So each of these plant species has a threshold, depending on what you want to grow. If you're growing kale, spinach, you can get down to 20-odd degrees. And just for a small period of time, it's going to be fine. So you're figuring out how to, whatever heat you are producing, inputs or stored heat, how to redistribute it. Okay? And you're really considering these ambient temperature thresholds for whatever crop you're looking at, trying to maintain it above those certain thresholds. Because if it gets below the threshold, if the fish freeze, you're sunk. So you're basically trying to maintain those thresholds, and if you had to, throw an augmentary heat source in there or something for certain situations. There's a concept floating around about the compost piles. And using compost, the process of composting generates heat. All these microorganisms building cities and so forth at a microscopic level, it generates a lot of heat. And so there's a concept where you build, what's the French guy's name? Jean Pen. Created a system where you build a big compost pile and run pipe through it, and then run liquid through that, heats up the water. And so you put that loop into the floor of your greenhouse. And then, so that cycle that's continuing all the time is just heating the floor of your greenhouse as it's also making your compost. So it's sort of dual purpose in that regard. And there's also the hotbed concepts, where you would dig out the beds of your greenhouse, dig like almost double dig, and then throw a bunch of high compost in there. That's
Fresh stuff.
fresh stuff. And then, put 6, 8, 12 inches of soil above that, and then grow in that medium through the winter. But that would set you up for, a 3-month period, well into the fall, perhaps.
And
You
you
know,
have to-
fresh manure gives
and then you
off
have to
a lot
do
of
that
heat.
again the next year.
But you're building soil
but you
fertility.
built the soil.
Right.
There's a lot of work in the
That was
process, but
reading Elliot Coleman's stuff. That's a lot of what the English and the French were doing
Exactly.
before the turn of the century, when horse manure and straw were very prevalent. So they were actually growing. Now, granted, they have warmer temperatures over the year, but they were growing under glass dishes, if you will, in a bed of horse manure and straw, and they were growing plants in that year round.
But what you just said, you put that under the soil. You'd have to take all that stuff out and put fresh compost in there to do it next year.
For a hotbed, you would, yeah.
For hotbed.
if you want to keep that root, but then you might not want to do that in the future. If you wanted to do it every single year, yeah, it's going to be a lot of work. But if you did it once, twice, and it would also build your fertility, and you get that season extension.
There are pros and cons on a lot of these systems. There are so many alternatives from a design perspective just for a greenhouse. So as Josh said, if you were to use a compost mound or a wood chip mound to create heat, you could also use a solar hot water collector. Or if you had gasifying furnace or a wood boiler that you were using and you, during the coldest times, wanted to take, off from there and use it. So there are lots of different options, and they all relate to what works best for your situation of structure, materials, and your goals for the structure. You're getting into structure materials?
My goal for a greenhouse is that it would only be seasonal, just to get things started. And I would like a root cellar as well, which I'm not really sure. I don't know if it's just one for the greenhouse building, but we have our house is up on stilts, so there is no basement.
Yeah.
So right now there's nowhere to preserve.
I would encourage you to look at how out of one structure, because I think you could do it, out of one structure with the appropriate thermal break between the greenhouse and the northern side where you might locate a root cellar structure.
Yeah.
But like how you could stack the functions of getting the different uses you want under the one investment in the roof and foundation. Because we did greenhouse, tool shed, chicken coop, social space, all under one roof.
Okay.
So you're saying like on the if this was a south-facing slope, you would build like a little retaining wall or some such here and put your greenhouse on that element and then dig into the hill, your root cellar?
Could, or even if you didn't have a slope, this could be an insulated wall.
Right, just on the
And an
flat.
insulated box.
On one side, and then on the north side you have your root cellar.
Yeah, and you could maybe go below grade
Right.
a little bit too. So I think it's not something that we can necessarily design in 5 minutes, not having been to your site, but I think it's something to start playing around with, that design. Because, I don't know if you're going to talk about structured materials, that's quite a drawing you get there.
Yeah. But this would be on structure side, thermal mass on one side and insulation on the other.
Okay.
So there would be a break. It's the thermal break. But yeah, in terms of structure and materials, the glazing is a principal component, yeah? With the glazing, you're looking for maximum penetration of the solar rays. Transmission rates will vary. You get some really opaque, some of that double pane glass that's the moisture's gotten all in it and everything. It's going to reduce transmission by like 50%. In the industry, you get 80-90%. Those are sort of the standards for this sort of product. And then when you're looking at the insulation value of your glazing, it's rated in terms of R value,
Right.
is the common term. And so a single pane of glass, which is what, a little bit more than 1/16 of an inch thick, probably a little bit lesser than 1/8 of an inch, is goes by R1. But it has the R value of 1. And this is another one of these exponential scales, like the pH scale, that goes up tenfold every number. And so you have like foam is what, like R7, some of the foam they make, some R4.
Well, it depends on
The thickness.
Of the quality of the cells and so forth. But basically, it's trapping air. And it's a measure of that. So what we're trying to do, we have some examples outdoors of some of this glazing material, but they're building now with polycarbonate. And so the polycarbonate is like UV resistant on one side, and then has cells in it, different cells. So imagine you're looking at it, it looks pretty clear looking through it, but then when you look vertically through it, you can see all these different cells that trap air. That's the gist of the polycarbonate. And it's really lightweight. We'll show you some of the materials, lightweight but very strong.
So when you're looking at materials, your goal during the day is to let that sun through and create this greenhouse effect. And like any glazing, it's just a heat loss at night. So it's a matter of trying to balance how much glazing you need to let the sun in to heat the space, and not have more glazing than you need, because at night you're going to be losing it, and you're going to have to look at double coverage like Elliott Coleman does with remade stuff down below, or like the passive solar greenhouses of the 70s had east and west walls fully insulated, north wall fully insulated. It had a very a narrow frame looking to the south. Try to reduce that.
Greenhouse strategies, in terms of the conventional greenhouse, we'll talk about hoop houses. So it's a typical structure. It's a lightweight frame, usually tubular steel, aluminum or something like that. Hoop house, Caterpillar. And you put something over that collects the solar energy and prevents it from leaving at night. And usually it's pretty thin plastic. Sometimes they'll put a double layer of that plastic in and blow air through it, sort of keep that
A little protection.
zone. In terms of getting more sophisticated, it is really this balance. Lots of these structures that got built initially to try to use passive solar overheat. Right? There's too much glazing per indoor square footage, and the glazing is not oriented as it's oriented for optimization. In some cases, too much, depending on the season. So we're going to use the example of the front of this building right here, because we're going to have a project ongoing this summer. We're kicking around the idea, and you guys will see it coming out. But from the top view, oh boy, from the top view, you have where we were in the kitchen. We were eating right here, yeah, and this is where the sink is and so forth. So we're going to take a projection out this dimension, and it's coming out 20 and coming across like 26. And the peak of the roof is like this. So you can see it in this view right here. So that would be the peak of the roof. And right here would be this corner. And so this is looking at it from the south. And so what we've decided to do on the design of this is leave the roof of it solid.
Why, Josh?
Why?
You can capture water.
Yeah, there's some water to it, element, but as far as it's going to be solid in terms of opaque. We're not even using the tinted glass. The tinted glass is pretty and might be aesthetically pleasing, but we're using just metal roofing because we don't necessarily need the summer sun. The summer sun travels almost directly overhead. And so for us, it goes right over the top. At that time in the year, June, July, August, it's directly overhead. Sometimes a little, almost to this incline. And so what we really want from this building is to get the morning sun in the winter, and the midday sun in the winter, and the afternoon sun in the winter. We don't want any more than that.
You don't need a hot house. You have hot houses.
Yeah, this is not for growing tomatoes. And if we did create it with a clear material on the top, it would overheat. It would generate temperatures of 120 degrees, and you would have to more actively ventilate this structure.
Is it going to be opening right into this building, or it's
Into the kitchen.
Which is, I mean, if you were to do this on one of your structures, it provides an opportunity, especially during the shoulder season and on sunny days in the winter, to generate that greenhouse effect and open the door, open the vent, and let heat into the first and possibly second story of the house. But in the summertime, you don't want to create additional heat in there, and you don't want it coming into the house. So when it's installed on the front of the structure, typically you have that opaque roof, and you want to make sure the wall's insulated from that space, so you're not overheating.
This is the terminology is a passive solar system, and so we just stand there and let the seasonal variations do what we want. Is the concept,
And that's why so much of it's tied to what your goals are.
and in this case with the passive solar, on this structure we're looking to heat fall, winter, spring, so we can burn less fuel. And we're also looking to extend the growing season, particularly in the spring and the fall. So this design meets those purposes.
Will it all be polycarbonate on the side here?
This is the super glazing stuff. This is like,
Nice glass.
it's like an inch.
So you're going to be heating the floor. I mean, you're looking for the contact of the sun to the floor.
Yep, we're going to have to put in a thermal mass onto the floor. We have to really choose that material. And then we'll also probably run through that floor tubing that we can heat exchange liquid either from the compost pile or from the wood boiler or from our domestic solar heating. So it all sort of tie into a big loop.
Should I talk about the climate battery as a concept?
Yeah, let's talk about the climate battery and then get back into ventilation as an overall concept.
Okay. So the system that we've used in our greenhouse that you'll see, the greenhouse is not attached to the home. It's a separate structure. And so in the summertime, doors open, we have extra heat because we have a fully glazed roof. You know, the whole roof is glazed. Parts of the east and west walls are glazed, and then the whole south wall is glazed. So when it's hottest in the year, with the doors open, I have too much heat because it just really creates this greenhouse effect. And then in the wintertime, on good warm days, I can produce the heat I need inside for greens and the things we're trying to do. But the higher portion, picture the ceiling here, the upper portion, heat accumulates, and it's not of use to me to the plants that are down here. So we're using something that's called a subterranean heating and cooling system. It's otherwise known as a climate battery. And it's an air system. And so basically, here's our greenhouse, looking from the south, and there's a roof going up. And we have raised beds. So you have a raised bed, and then below the greenhouse floor, we have sand. And what we've done, sorry, multiple colors. I think it's Eddie the other one. Climate battery. So what we've done is we've put 2 half barrels under the floor. These are like just regular polyethylene rain barrels, cut in half. So they're open on the bottom, so any water that would accumulate in the system can drain out. So there's these 2 barrels. There's a stack that goes way up. And there's a small stack. This is the exhaust. It has a fan that draws heat down. It's all controlled by thermostat. So we have a thermostat here that says, hey, it's too hot up here.
Say
Turn
80 degrees? Or?
We can set it, right now I think it's set at 85.
Okay.
So yeah, it's 85 degrees. Turn the fan on. All that warm air from the upper part of the greenhouse gets sucked down and gets distributed through pipes under the beds that have perforations in them. They're just 4-inch drain pipe, black drain pipe that goes like perimeter foundation, upper foundation, things like that, and have little slits in them. And this is taking this heat, this warm air, forcing it down into the ground and out into the sand. And the tubes you're seeing here from the side, the tubes radiate out. They're all the same length. They're 20 feet. And they all go out in pairs, equal distance. And then that air comes back up here, cooler. It's storing heat in the ground, coming out. You'll feel it. It'll be cooler. What happens here is even on a cold winter day with a little bit of sun, we're getting 85 degrees, no problem. We're storing this in the ground, and that heat is then able to kind of radiate up through the root system of the plants and keep them pretty happy. You also have the ability to have a lower thermostat here for nighttime use. That would be to say, if it goes below 40 degrees, turn that fan on and take the cool evening air, heat it in the sand, and bring it back up. So it's just a different system. It's the same concept as bringing the hot water in from solar hot water or compost pile or something, but we're using the excess heat at the top. Right now, like the weather we've been having, I opened the doors of the greenhouse at 6:30 this morning. Yesterday I wasn't around and my wife forgot to. And I checked the data logger and we hit 125 degrees with the doors closed. And there were some plants in there like, like that. And they came back, they're fine. But it was not ideal. But you could have mechanical ventilation. It all comes back to like how involved you want to be and how many moving pieces you want to have.
Yeah.
There are lots of options. Lots and lots of options.
Yeah, and I think the point is well taken that you can overdo this with the plants as well. We talked about overheating houses, but you can kill plants just like that. Exactly that. All right. Well, in terms of ventilation, I mean, you got your hoop houses.
Give me that one.
Get rid of that one. You got your hoop houses. Typically, we'll see ours up there. They have roll-up sides. It'll take them up to a portion, and you get that. And also on the ends, you might have like an end fan. I think for us, we try a lot of mechanized fans and so forth, and it is just a lot of energy invested in trying to cool off and ventilate spaces that we've more or less created the environment. So it's trying to figure out as much ways to have operable or some sort of mechanized system to get these spaces opened up when they need it. It's not necessarily even, it is the temperature to a degree. Some crops just aren't going to take extreme heat, but it's also just getting fresh air, and you'll develop disease and fungal problems much more readily in a high humidity environment that doesn't get adequate ventilation.
And that's been interesting. I think we may have mentioned to you guys, Jonathan Bates has a blog, Backyard Bioshelter, and it's based on the bioshelter that he and Eric built in Holyoke, Mass, which is a very tight envelope. So Josh talked about the envelope being tight, so there's not a lot of air exchange. It's super insulated with foam on the east, west, and north walls. It's a good frame, a structure for dealing with snow load, but they had a tremendous amount of moisture buildup over the winter. So they had a lot of greens going. They have a lot of thermal mass. They have a hydroponic, aquaponic system with fish and with watercress and with other stuff happening in there. And there's a lot of moisture, and they started getting a mold problem. And he came to visit ours to look at this system and made a really interesting observation that I hadn't made, because not only have we not had moisture issues, there are times of the year where I like to have more humidity. And I don't have enough water in there yet to kind of create that. But he made an interesting point that my hot my warm, wet air is being introduced to the ground, where it's probably hitting its dew point there, and depositing the water in the ground.
Right.
So it's been controlling our moisture.
Cool.
So yeah, we can create problems really quick in a greenhouse too.
Yeah, I went to Hampshire College, and there's a greenhouse housing. That greenhouse was like built in the 70s by a bunch of stone hippies, and it like rotted off the building a few years after I graduated. Like we saw it in a lot of the greenhouse, like air. It was really moist. Like there's always the smell in that house. It wasn't bad, but it's that like greenhouse smell. But it was just slowly biodegrading some things, and so I was wondering, how do you prevent that?
Oh, you're creating a very biologically rich environment, for sure. I think a lot of it is just trying to create structural allowances for that, like the wood elements, trying to keep them out of the soil, not contaminating the structure with your growing medium, and so forth. Definitely, a living soil will degrade a building pretty rapidly. But I think ventilation is
Huge. The material selection.
yeah.
You're gonna stay away from wood in yours?
This one coming up, I think we're really shooting to be just high and dry
Right.
in terms of the foundation, and then looking for ventilation.
So as far as materials?
Materials,
structure.
this is one of those prefabricated units.
So it's aluminum framing?
I'm not doing the install. I'm going to watch it. I'm in charge of getting the foundation ready. So,
But the material, what types of wood generally have you used in the other structures? It's been
well, you got hemlock is really resistant to, say, moisture, but it could also be more pervious to UV. I like pine lots of time, but your cedar works well. Tamarack would work well in wet applications. Yeah.
black locust, but it's heavy as heck.
Yeah. Black locust could be oak, very effective in pretty much everything.
Chestnut, but we don't have any.
In terms of what's out there for construction materials, just had a friend construct a greenhouse off the side of his building and took a old modular home chassis
You have them.
and craned it into position on the side of the house. So I mean, it's a structure.
And impressive does not even do it justice. It's
Put,
really amazing.
put 2 beams, 3 beams, a post system on it, and then just craned that whole chassis into position, and then just put the glazing on top. It's actually longer than the whole structure. So right up here, he's putting like his renewable system, and then his greenhouse element is down here. I'm just going to have his flowers. So the sun can get through there. But yeah, it's just, there's a lot of steel out there. And I guess if I could recommend a material that's readily available at this juncture, I would go ahead and jump on steel.
Steve was saying he's got a mobile home on his site he wants to get rid of.
Yeah, got the time.
Demolition.
Problem is the solution. Right?
Yeah.
For sure.
Other questions? Yeah, Doug.
With your greenhouse bed, did you talk about the design phase? Obviously, this is unique. You didn't get it from somebody else. Did you build a concept? How did you know your pipes were the right thickness? You cut the right amount of slits. Talk to you about how you.
Okay, so Central Rocky Mountain Permaculture Institute in Basalt, Colorado, and they were the ones that came up with this concept. So I took it and used it. On their website, there's a whole section on resources, and there's a link to subterranean heating and cooling systems, and it's basically an open source of information, including a spreadsheet on how to design.
So it was already sized and calculated.
It's not perfect. You have to. It helps you figure out your cubic feet of space that is being heated, and what the air exchange you're looking for. It gives you a range, and you decide. I think mine's 240 cubic feet a minute, something like that. So there are some parameters that you have to decide, but then it helps you figure out, when we go up to see the hoop house, if Josh wanted to do a climate battery in the hoop house, he'd have a couple of these systems where there'd be an intake and an output. Mine, I only needed one input-output, and it helped me figure out how many pipes I needed and what length. And it gives you some general guidelines about having the pipes be the same length, so there's a tendency for the heat to spread out and not go to one spot.
Okay.
But it was not pioneered by me at all. They're just, at the time, there were no examples of it in the Northeast. Now there are a couple, which is cool. So we're all kind of like sharing information. And mine is run on the solar system, so I have 2 solar panels and a battery bank that run that fan and provide light and power to the greenhouse just as needed. But what I found is that during the day with 2 solar panels, I'm getting enough energy generation to run the fan. So this goes back to what Josh said, like how much it's energy intense to ventilate or do anything. So I'm getting energy to run the fan, but not enough to really bank enough to run the fan at night. So I'd have to expand on the system to be able to run the fan more in the evening. So I haven't been getting the full effect even of the evening circulation, and it's still been fantastic.
It sounds like one change you'd make to your design though is maybe some solid panels on the slope. Just
I don't know if I would. I probably could have reduced the amount of the roof that's translucent, but we use it in the summertime for eggplant, tomatoes, peppers, stuff we would normally struggle with outside.
Right.
So it's been good to have it as a hot house. But now I'm starting to bring the ground temperature up later in the summer and into the fall, and trying to keep it from freezing. Because as Josh said, once it does, and we have ours is insulated, it's got like a skirt of insulation coming out this way. So like 2 feet all the way around the perimeter. I think if I did it over again, I would have come down and insulated it like that.
What kind of material?
It's just a foam. Yeah, just like the 2-inch blue foam that we were able to salvage from people's construction sites, and we didn't do that much to do that. But I think I may have even purchased some foam because the frost still does kind of creep in, and once it creeps, you have it, and it's cold. It's hard to reverse that cycle, that glaciation.
Yeah, I would just speak a little bit. I've used it a bunch, and I'm a little bit skeptical of this foam stuff, especially buying it new. I've been taking apart coolers, the foam coolers.
Yeah.
Hope to use some of that for these sort of applications potentially, but I mean, it generally, I guess I'm a little bit more confident in the stuff when it's out of ground contact, and it just seems to retain moisture at some level, even though it's a closed cell product. I've seen them get waterlogged.
Right.
And so once they're full of water, they're not going to be effective.
Yeah, you're welcome. Other questions related to greenhouses or greenhouse design?
I've just been struggling with trying to integrate everything into a single building so that my buildings, serve as many purposes as possible.
Right.
And it's just there's so many little details that if you want to get into it, you can certainly get into it and make it one heck of a project. But it's like, where do you stop with it?
To me,
Space constraints.
yeah, greenhouses and this design element, when we're getting into design build really in a big way here in this conversation. And yeah, there's a whole lot to that, just like pacing out stuff and laying things out on, blueprints and so forth, but as well as just figuring out how floor plans would work and roof pitches and what usable space. It gets a little overwhelming.
And then integrating purposes, because I wanted to make my sheep shelters also double as a chicken shelter, and then I wanted to put a solarium on that as well, so that I can, right there, I can take the sheep poop and the old hay and all that, and the same thing with the chickens, and I can, I don't have to move it anywhere. I just move it into the other room, compost it. But trying to combine all these things is, I don't know.
Well, I would say don't wait for perfection, because it's not going to happen in this lifetime. And just try to get your focus on, go ahead and implement one with the eye towards maybe adding on, building an addition. But go ahead and make the move. Don't sit and dwell on this
because
too
you can
long.
sit and dwell on it forever.
No.
And you won't get it all. Like what we did was the chickens are in the back. So if you picture that this back corner, the northwest corner is insulated, and the chickens are in there. And so the compost bins are out here. So the chicken waste comes out, but it needs to be finished, and then it can come in. So there's an additional step in there, but they're both located in proximity to each other. And then inside the greenhouse, where this big stack had to be, we built a deck. And so the stuff that really likes heat, like moringa trees and things like that would normally grow here, those are all up here. And you can sit up there, and because of the translucent roofing, you can actually be seen from the road. We face a road. We face a busy road. People know we're out hanging in the greenhouse. We have visitors, and maybe you just want to read a book and be in a warm environment in your underwear or something. So you can sit up here. And then our roof, we can capture water off it, but we didn't want to put solar panels on it, and it's our south-facing roof. So we ended up building a small roof above for mounting solar panels and making use of the space over the chicken coop and the shed. So you end up with like a greenhouse that's 14 feet tall and a chicken coop and a shed that are 10 feet tall. And then you end up with this 4-foot wall, and you can hang a hammock up there under that roof. So we end up with a place you could get high, could be in a hammock not seen from the road, because that kind of like sense of place and privacy was important, and get a nice breeze in the summertime. So there are some things that you can over time. It took us like 3 years of like kicking that. Like, what else could we add? And no, we can't do gray water in there. I would love to have a gray water system in there and be sending hot water to the greenhouse, but it's just too far from where we're generating gray water. So the things that just say no, it's not going to work.
Yeah, I mean, do the things you know need to get done. And some of this stuff, stew on it until the time is right and you really feel good about it.
But at some point, you just got to do it too.
Yeah.
Right?
And I guess a couple more things. In terms of the greenhouse and the greenhouse concept, I can't really overestimate how the pleasure of the space, the beauty of the space, and being in there either in warm conditions, when it's cold, sunny conditions, the plants, being in that ambiance and so forth with the plants, like it is really a nice place to be. So I can't overemphasize that. So you really want it to be user-friendly in that regard. You don't necessarily want some crouch space. I've been in some sort of subterranean ones where you're like hunched over. It's less fun.
You might want potty tables and places to work,
yeah,
so you're comfortable.
Oh, golly, a little hammock maybe. Seriously. And then in terms of this whole design build it concept, the elements before you build something. I mean, I've been building stuff for a long time, and if I don't go through a lot of this process, I will make lots of mistakes. I would advise you to draw it. Seriously, just draw it. And then communicate it to somebody. Just like use that to drawing and communicate it, and then that'll help you think about it, and they'll give you some advice and feedback. And then somehow either mock it up,
Make a model.
It doesn't have to be a scale model, but sometimes a scale model is nice, or at least some element of it. The roof pitch, put one rafter up before you decide that's the height of the beam. Figure out, walk through the house and look to see where you're going to put your windows before you build the house. Sometimes I think you don't. I sometimes won't order my windows until the beams are up, posts and beams are up, so you can figure out where exactly you want to place the windows and so forth. And then within that, before you're constructing and so forth, really try to pace things out. Like if you have drawn a picture and this is 12 by 16, like paste that out on the ground. Take it and put some stakes in the ground, that sort of thing.
Yeah.
And that'll really get you some places. But staking it out in the field and maybe figuring out how to anticipate how the roof lines are going to be and the square footage and working spaces and so forth. Before you start digging.
It's huge. It's going through that permaculture process, as Josh has just said, we were doing that. One of the things, at one point I drew the greenhouse from the side was like this. And so you had the greenhouse from the side, and then you had this upper story where I was going to have like not only the solar panels for the greenhouse, but the solar panels for the whole property. And I was like, cool, that's going to totally work. I was all excited, and I drew it. I explained it to Charlene, and she said, how much snow and ice is going to come off this? And I was like, oh, crap. I'm going to turn it the other way. And then I end up with a tiny little roof for just solar for this. But a tremendous amount of rainwater catchment. But it was like, wow, yeah, that could have been pretty rough on the polycarbonate.
Alright, yeah. So we're going to go out and do a little greenhouse walk. This is the polycarbonate without the cells up in here. And we're not really concerned in this about the so much about the ventilation. Like we didn't really work very hard to seal this space. We just don't really need to. It's plenty warm in here, particularly for this time of year. And the ventilation is so crucial. So just getting this up a couple degrees and keeping the wind off it really helps these plants. This is a nursery. So we're trying to create a hospitable environment for the growth of plants. And a couple degrees warmer and a little less of those harsh conditions that can be prevalent in New England this time of year, the breezes. But the greenhouse element, as far as its orientation, it really was a question of how to angle that back wall so we could maximize the eastern and the western as well as the southern exposure. And also situate it so it wouldn't be in the shade of this building. Slightly in front of this. But too, getting the beauty is figuring out this whole system. The sun is getting pretty darn high, yeah? I mean, it's almost behind me. It's almost due west. So this comes in, when we get into figuring out how that greenhouse is going to work, that's really, we're looking for more shade in the summertime. Well, let's go in here and just check it out. I like it in here because you don't have that temperature spike. But how much glazing there is, we don't really get a huge temperature spike. Like with this much glazing, you normally anticipate the temperature to get too warm in here. But the huge thermal mass of the center of the structure acts to cool it. So you could do it also with water, if you've stored a bunch of water in tanks in here and so forth.
You guys remember how small the greens were in these beds?
Yeah, they were. It's been a progression.
The other thing I like about this greenhouse that we would come up and look at Josh's greenhouse and talk to him when we were thinking about doing ours, is the 1970s kind of new alchemist greenhouses with the east and west wall heavily insulated. They really are effective, but you have like no view shed. Like there's a very small view shed out to the south. And here you feel like you're kind of outside, which, as Josh said, on like a cold time of year, on a nice day, I didn't want to feel like I was like locked in and I could only see out in one direction. So we lost a little bit of energy efficiency by opening up the east and west walls, making them translucent, but then we get some of that morning and evening sun, which is helpful too. It goes back to design.
So interesting too about this helping cool, not just heat, but cool as well.
Right.
Because that's what I'm thinking. One side of my greenhouse is going to be a masonry wall, so that's going to be able to have the same effect ultimately.
And figuring out different ways to potentially use that almost like a trom wall.
Right.
You know, you can even set up some sort of ventilation scheme within that wall itself.
Yeah, lowering the windows.
Cool. Let's keep going on to the next greenhouse.
All right.
Alright, you know, that's sort of augmented by this greenhouse. I like this space a lot. You know, I think a lot of people are really into killing themselves about making these super tight, like, just as efficient as possible. Efficient. And I think they're stuck in the scientific paradigm where they're only pushing one threshold. They're not pushing the complexity of the system. This thing works really great. It's wide open on the backside. But it provides shelter, controls humidity to a degree and the moisture in the soil, and we can really focus our agricultural potential in here. And it's well defined. What definitions are really nice in gardening. That's why some people just make squares. That's all I can think about, you know. But in this part, it is sort of nice to just know how far you have to weed through the walls. But there you have it. I think the ventilation is just so crucial to see how much air is passing through here. It's not sealed tight, but by the same token, it's a shelter. So it's a combination. And boy, yeah, the spinach is good. And stuff like this too, you don't want the spinach to overheat. So it's about picking that crop that you really want within this growing environment. So this greenhouse is very productive for us. It's been set up since we got here. So you figure this is 15 years old. It's collapsed already one time. Severe collapse. Screens in it. Totally harvestable. March storm collapse. We've reconfigured it a little since that time. Holds up rather well now. It's leaning in one direction. But, you know, it's a super productive salad greens beds. There's spinach and chervil and lots of claytonia in here now. Looks like some lettuce, some kale actually overwintered. That's super cool. Anything to comment on it? It's really small space, but comfortable. I think the important things to consider when you get into laying stuff like out of this, I'm not sure what this is. I think it's 10 by 20. No, it's probably more like 12 by 20 in that realm. And just how to configure your garden beds to maximize the space. How to make sure you have access to all the different zones of your garden bed. We used to have big tanks in here of water. You do that as well. And then just look at the roll-up sides, how that component works. I think, you know, the issue with these is the plastic. You know, this plastic is super old. If we were going to really be commercial fancy growers, they would recommend replacing the plastic like every 3 years. But we get as much life out of it as we can. And but it degrades.
Just we could mention on this one, Josh, that the size of it enables it to be considered as like for a movable greenhouse.
Oh yeah!
A rolling thunder
Movable. Have you guys done any of that, Jobby?
So then you could actually take it through the growing season and put it over different spaces.
Do you guys see how that would work? You more or less put it on wheels.
Yeah.
Cool.
Roll it
Put it
along.
on tracks. Sure.
So it allows you to like start crops that are, you know, sensitive, and then move it forward and start some more that are super sensitive, and sort of keep that cycle going. Sort of like a crop rotation pattern.
Yeah.
Should we go from here up to the other hoop house?
Yeah.
Wow, it's hot in here, isn't it? I think we should open up the sides more. I'm all for it. Does someone mind opening up the sides just so we can see how that works? Yeah, roll it up.
You want it all the way up to the...
Until it gets sort of tight, until you get some resistance.